Hey guys, so in this video we're going to be looking at equations of tangents and normals. So we've briefly talked about what tangents and normals are before. However, this time we're going to find the equations of them, no matter what type of graph we have. And to do this we're going to be using differentiation. So what are tangents and normals? I'll just quickly go over them again. So if we have an equation here, so y equals x squared, then we look at a particular point. So say x is equal to a. So at this particular point, the equation is going to have a certain gradient. So let's say gradient equal to m. And then if you pick different points, you can see that there'll be different gradients at all these different points. And then if it was a straight line, every point you would pick, there'd be the same gradient. So what is a tangent? Well, the tangent is a straight line, so a line in the form y equals mx plus c, which has a gradient equal to whatever point you want to pick. So you have a tangent at a particular point, and that's this gradient, but it also goes through this point, which we'll call AB. So let's say x is equal to 5, then this point would be 5, 25, because you can sub it into the original equation. So getting this, we then draw the line with the same gradient, and then intersecting through this point. So it could look something like this. So that would be the tangent there, and it would have an equation y equals mx plus c. So it's a tangent. So what is a normal? Well, the normal is perpendicular to this line. So that means it's going to look like this, and there's going to be a 90-degree angle in between. So the key feature of the normal as well is that it still intercepts through this point AB. So this point here it still goes through, and then it's perpendicular to the other line. So that means its equation will be, well, it's going to be a straight line, so y equals mx plus c. But if you remember with perpendicular lines, the gradient is equal to, the first gradient is equal to a -1 over the second gradient. And you can rearrange that to also get m2 is equal to -1 on m1. So that means if you know the tangent gradient, you can therefore work out the normal gradient. So they're both straight lines, you find them at a particular point, you find the gradient, you use this point, and then you can find the equations of the different lines. So we'll use this as an example, y equals x squared. So let's take the point x is equal to 3. So this point x is equal to 3. Then we have to find what is the gradient at this point. Well, we can do that by, if y is equal to x squared, then dy dx is equal to 2x. Now we sub in the point x is equal to 3. So let x equal 3. And therefore we know the gradient at this point is going to be 6. Then what is this particular point? So we know the gradient of this point, but what is the actual point equal to? So that is 3, 9. So x is equal to 3, then you sub it into this equation and we get 3, 9. So we have the general form of a tangent, which has to be a straight line. So we sub in this gradient, we know it's 6. So we get y equals 6x plus c. But how do we solve for c? Well, we sub in this point because we know it has to intercept through this point. So we get 9 is equal to 18 plus c. So x is 3 times 6 is 18, 9, and so we get c is equal to -9. Therefore, the equation of tangent is y equals 6x minus 9. And graphically, like approximately, obviously it's not to scale or anything like that, we have y equals 6x minus 9. And if you're doing this properly, you'd have to draw in the x-intercepts and the y-intercepts as well. And also for the y equals x squared, so you'd have this point here, 0, 0. So what about if we now want to find the normal? So the first step of finding a normal is working out what the gradient is. So if we want to work out the normal, we know it's a straight line, so we know it has a general form y equals mx plus c. So we knew the tangent, so we'll call the tangent m1, gradient was equal to 6. Therefore this m, so m2, is going to equal -1 on m1, so -1 on 6. Therefore we get the equation y equals -1 on 6x plus c. Now the tangent also has to intercept this point here of 3, 9. So we can sub that in to work out what c is. So that means we're going to get 9 is equal to -1/2 plus c. So c is going to be equal to 19 on 2. Therefore the equation of the tangent is y equals -1 on 6x plus 19 on 2. And if you graph this, especially if you're doing to scale, you'd be able to see it goes down like this. You have the equation like that, intercepts a point at 3, 9, then this equation here is equal to here. So that is how we can find the equations of the tangent and the normal. However, note that it does change on the specific point. So it is important about what x point you do start off at, or what point you do start at. So a question could actually give you a y point. For this one we can't, but if it was a one-to-one function, they could give you a y point. So let's say we had an equation y is equal to square root x. Then they say y is equal to 4. So when y is equal to 4, x has to equal 16. So because they're giving you the y point and you have this equation here, which is 1-to-1, you can therefore work out what the x point is, differentiate it, sub what x is equal to, and you can do the same method that we just did then. So in summary, here are the different steps to find the tangent and normal at a particular point, such as x is equal to a. So the first step is always differentiate the equation. So once you differentiate the equation, then you can sub x is equal to a into dy dx, to find the gradient. Because at the particular point, whatever the gradient is, that is what the tangent gradient is. So we're looking at the tangent. So then you sub the gradient into y equals mx plus c, because for both tangents and normals, they are linear lines. Now you sub x is equal to a into fx to find the original point. So sometimes they'll give you the original point, such as they'll say like 2, 6, and then they give you the x and they also give you the y. However, if they just give you the x, then you have to sub into the original equation. So not dy dx, but the original. And then you can find the original point that both the normal, the tangent, and the graph all intercept at. So you sub this point into y equals mx plus c. So you already know m. So this is effectively to find c. And once you've found that, you'll have the tangent equation in the form y equals mx plus c, where you know m and you also know c. So that was to find the tangent. So what about if we wanted to find the normal? Well, if we've already done the previous steps, then the first step is to find the gradient. So we can find this via m1 is equal to -1 on m squared. So this is assuming you've already worked out the tangent, and if you already know the tangent, then you already know the gradient. If you don't know the tangent, then you'll have to go to the previous steps. You don't have to go all the way to the end, but you will have to find out what the gradient is at that particular point. Then once you find that out, you can sub it into this formula here, and you can work out what m is for the normal. So you sub m into y equals mx plus c. So sub the gradient into the equation of the normal, which once again is a linear line. And then you can sub the original point AB into the equation. And this is to solve for c. So yeah, solve for c. And once you have that, you'll have the equation of the normal in the form y equals mx plus c. However, note that the m's will be different compared to the tangents and normals, and because of that, the c's will also be different as well.